Hi, Calculus 1 students. So before going any further, I want to mention that this example is for my section 18. There we go. It's for the section 18. And it's because we didn't have the time to do this problem in class, but we need to move on with the material. So here it is. Find y prime prime, so the second derivative, in other words, for the curve x to the 2/3 plus y to the 2/3 is equal to 4. So this curve is called an asteroid. If you plot that on Desmos or GeoGebra or any other type of software, you will see actually y. Okay, so the first step is the same as usual. We're just taking the first derivative, and this time around, we're going to simplify the first derivative. So, all right, I'm just going to write here step 1, and I'm going to just put both sides of this equation, leave myself some space, and write the d over dx on both sides like this. Okay. So I always do this to remind you that y is an inside function. Okay, so we've seen how to differentiate a lot of examples like these in the class, but okay, so this derivative is the simple one, 2/3 x to the negative a third. And here, just a quick reminder, just like a suggestive color code, you do the outside inside rule. So, okay, the derivative of the outside is 2 over 3 y to the negative 1 over 3. And the derivative of the inside is y prime. And now, of course, the derivative of 4 is equal to 0. Okay. Now we're going to solve for this. So it's pretty straightforward, actually. So, okay, let's just write this, y to the negative a third, and then y prime is equal to negative 2 over 3x to the negative a third. And before we move on, let's just notice that we can cancel the common factor, like we can cancel the 2/3. And what we get is a resulting y prime of, okay, so first we're going to get negative x to the negative a third. And then instead of, okay, so actually, yeah, let's actually do it. Divide by y to the negative a third. But what I would like you to do instead is to move it up and bring it up to a positive exponent. So the reason for this is because it will ease our second derivative. Okay, we know where we are. We know where we are going. We know that we need to take another derivative. So for that reason, you're going to write it as a product like this in order to ease as much as possible your work. So the step number two, it's actually, you're going to take a regular second derivative, but there is a twist. Okay, so in other words, you're going to go like y prime prime, that is equal. So you're just going to take this and differentiate it with respect to x. Okay, so d over dx of the bracket. And then the derivative is a simple product rule. You do have to be careful again about the y, right? Whenever you see a y, you have to think chain rule. So you have to take the derivative of the outside function and multiply it by the derivative of the inside function, which is going to be y prime in this case. So that being said, it's not the rule we start with. We start with the product rule. So the product rule will give us here, so this derivative will be positive a third, x to the negative 4/3, multiplied by y to the 1/3, plus negative x to the negative a third, times outside inside rule, so 1/3 y to the negative 2/3, multiplied by y prime. All right. Now here's the twist. we want to find y prime prime in terms of x and y. But the problem is that we found it in terms of x, y, and y prime. So this guy over here is a problem. But we should realize very quickly that y prime, so we have it over here, it's this red box. Meaning that we will actually substitute it in. Okay? So, and this is our next step. So, let's rewrite the first term as it is. I'm going to drop the color code. Resist for now the temptation of putting everything as a positive exponent. You will see later on you will be rewarded. And here, okay, so let's put the minus outside. So x to the negative 1/3. I'll put the 1/3 in front though. So negative 1/3, x to the negative 1/3, y to the negative 2/3. And then instead of y prime, we replace this box, right? So we replace the negative x to the negative 1/3, y to the negative 1/3. And before doing anything else, I think I would just simplify this mess. So, okay, I don't touch this. But here, okay, so negative times a negative will give you a positive. So positive 1/3. Then you add up the exponents. So just a little bit of color so that you can see this clearly. You add this exponent with this exponent, resulting into x to the negative 2/3. And the same thing happens for the exponent that is right here. So you add up negative 2/3 and 1/3. So you're going to get y to the power of negative 1/3. Okay. The next step. You might remember when we talked about simplify by factoring. If not, you can have a look at the corresponding YouTube video in the section 3.4. But the idea is to factor each term to their lowest exponent. So, for example, we're going to factor the 1/3. Okay, so this 1/3 that's over here. And let's actually write the factors as we think about them. It's going to make things easier. And then, okay, so we have the x's. The lowest exponent is this one right here. And this is the one we factor out. So x to the negative 4/3. And then we look at the y's. Lowest exponent is here, negative 1/3. Okay, so that's what we factor out. Okay, now let's write what remains. Okay, so here 1/3 is 2/3 higher than this. So we're going to write here y to the power of 2/3. And then if you look at the orange factor, 1/3 is, we already did that. Sorry about this. Now let's have a look at the second term. There you go. So it's here that we have something left remaining. And negative 2/3 is 2/3 higher than negative 4/3. So what you're going to get here is x to the power of 2/3. Okay, I'm going to finish the problem over here. Okay, so I'm going to finish over here because I'm very close, actually. So the point is that this turns out to be the left-hand side of this equation. Okay, so have a look. Like this guy right here. Or I don't even need to color code it. Like I can just use the blue as being my color code. Or actually, no, I will color code it for the simple reason that I will drop the color code of everything else. We will use this equation to simplify it. Okay? So what does it mean? It means that our y prime prime is simply going to be this. Okay, so 1/3 x to the negative 4/3 y to the negative 1/3 multiplied by the 4. Okay, that we get from putting this equation in. So I think the last thing I would do is literally just to put the 4 with the 3. So 4 thirds. You could, if you wanted to, move the exponent at the bottom. So this is something I like to do. I always like having exponents to have positive values. But if you're not doing anything with the derivative, like if you're just getting it, I think you should do as least algebra as possible on it. So this is your final answer. I hope this was helpful and see you in the next video.